Welcome to Module 7, The Future of Artificial Intelligence. In this module, we are going to step back from the individual methods and systems we have studied so far and look at the broader direction of the field. Artificial intelligence is no longer only a technical topic that belongs inside research laboratories or software teams. It is becoming part of how organizations make decisions, how workers complete tasks, how governments think about policy, and how societies imagine the next stage of technological change. So our purpose here is not to predict the future with certainty, because no serious scholar can do that, but to examine the forces that are making certain futures more likely than others. As we begin, it is useful to remember that the future of AI is being shaped by several developments happening at the same time. Computing power continues to improve, cloud platforms make advanced tools available to more people, and specialized hardware has made it possible to train models at scales that would have been unrealistic not very long ago. At the same time, organizations are collecting and storing enormous amounts of data, which means AI systems can learn from more examples, more contexts, and more kinds of signals. New architectures, especially those connected to deep learning and large language models, have also changed what people expect AI to do. The result is a field that is moving quickly, but not randomly, because these technical foundations are pushing AI toward broader and more flexible forms of use. This module also asks us to pay close attention to generative AI, because generative systems have changed the public conversation about artificial intelligence. Earlier AI applications often worked in the background, classifying transactions, recommending products, detecting patterns, or supporting analytics. Generative AI is different because it produces visible outputs that feel closer to human communication, such as written explanations, images, software code, summaries, and other complex artifacts. Large language models are especially important because they connect statistical learning with language, and language is one of the main ways humans organize work, knowledge, and instruction. That is why these systems are affecting education, business, software development, research, media, and professional services so rapidly. At the same time, we need to approach the future of AI with intellectual discipline. It's easy to become either overly optimistic or overly alarmed, but both reactions can prevent careful analysis. An optimistic perspective emphasizes the potential for innovation, productivity, scientific discovery, and new forms of human capability. A critical perspective reminds us that the same technologies can disrupt labor markets, increase inequality, concentrate power, and create difficult governance problems. In a graduate level study of AI, we should be able to hold both perspectives at once, because the future will probably contain real benefits and real risks unfolding together. The workforce dimension will be especially important throughout this module. AI does not simply replace jobs in a mechanical way, and it does not simply make every worker more productive automatically. In many cases, it changes the structure of tasks, removing some forms of routine work while increasing the value of judgment, coordination, domain expertise, and the ability to work with intelligent tools. This means that the economic impact of AI will depend not only on the technology itself, but also on how organizations redesign roles, how educational systems respond, and how policymakers manage transitions. When we talk about the future of AI, we are also talking about the future of work, training, opportunity, and institutional responsibility. That is why this module should be understood as both technical and social. The technical side helps us understand what AI systems can do, why they are improving, and where their current limits remain. The social side asks who benefits, who carries the risk, and who has the authority to guide these systems responsibly. Good analysis requires both, because a powerful AI system, deployed without context, can create as many problems as it solves. By the end of this module, the goal is for you to develop an informed perspective rather than a simple opinion. An informed perspective is built by comparing evidence, recognizing uncertainty, and understanding that AI development involves technical, economic, ethical, and social choices. The long-term implications of artificial intelligence will not be determined by algorithms alone. They will also be shaped by the people who design these systems, the organizations that deploy them, the incentives that guide their use, and the rules societies create around them. That is the mindset we will use as we move through the future of artificial intelligence. In this slide, we begin with the first learning objective, which asks us to analyze the emerging trends that are shaping the future of artificial intelligence. That wording matters because the future of AI is not being driven by one isolated breakthrough. It is being shaped by several reinforcing developments that are moving together: stronger computing systems, more available data, new model architectures, and large-scale machine learning techniques. When these trends interact, they do more than make existing systems faster or more convenient. They expand the problems AI can address, the environments where AI can be deployed, and the expectations organizations have for intelligent systems. The first trend is the continued advance in computing power. Modern AI depends on the ability to process enormous numbers of calculations, often across very large data sets and complex model structures. As hardware improves, and as cloud-based computing becomes easier to access, more organizations can train, fine-tune, or deploy models that once required specialized research infrastructure. Computing power alone does not create intelligence, but it does make certain forms of learning possible at practical speed and scale. A model that can be trained, tested, updated, and deployed within an operational timeline becomes useful in real organizational settings. The second trend is increased data availability, and this is just as important as raw computation. Machine learning systems improve by identifying patterns, and those patterns become more meaningful when the system can learn from larger, richer, and more varied sources of data. In many industries, data now comes from digital transactions, sensors, user interactions, documents, images, audio, logs, and connected devices. That creates opportunities for AI systems to recognize relationships that would be difficult for humans to detect manually. At the same time, more data does not automatically mean better AI because data quality, representativeness, privacy, and governance still matter. The future of AI will depend not only on how much data is available, but on whether that data can be used responsibly. The third trend involves new model architectures. Earlier AI systems often depended on models designed for narrower tasks, and many of those models still remain valuable. Newer architectures have allowed AI systems to process more complex forms of information and capture more sophisticated relationships within that information. Deep learning architectures, transformer-based models, multimodal systems, and other emerging approaches have made it possible for AI to work across language, images, code, and structured data in more flexible ways. This architectural progress is one reason AI is moving from task-specific automation towards systems that can support reasoning, generation, classification, retrieval, and interaction within the same workflow. The fourth trend is the growth of large-scale machine learning techniques. Scale matters because many modern systems gain their capabilities by learning from very large collections of examples and by using models with many parameters that can represent subtle statistical relationships. Large-scale training has helped produce systems that can generalize across tasks more effectively than older, narrower models, especially when combined with fine-tuning, retrieval, feedback, or other adaptation methods. Still, scale should not be treated as magic. Larger systems may be more capable, but they can also be more expensive, harder to interpret, more difficult to govern, and more dependent on the quality of their training data. What makes these trends especially powerful is that they reinforce one another. More computing power allows organizations to train larger and more complex models. More data gives those models richer material from which to learn. Better architectures help the models use that data more effectively. Large-scale techniques bring these elements together into systems that can be deployed across many domains. This is why the slide concludes that these developments are expanding AI capabilities across industries and society. The expansion matters because many fields now depend on patterns, predictions, communication, or optimization. For a graduate level analysis, the important point is to avoid treating AI progress as inevitable or simple. These trends create powerful possibilities, but they also raise questions about cost, access, accountability, environmental impact, bias, security, and social consequences. An organization that adopts AI only because the technology is available may fail to understand where it adds value and where it introduces risk. So, as we study emerging trends, we are not simply listing technologies. We are examining the forces that are changing what AI can do, who can use it, and how deeply it may become embedded in economic and social life. In this slide, we turn to the second learning objective, which asks us to evaluate the role of generative AI and large language models in modern AI systems. This is one of the most important shifts in recent artificial intelligence because generative AI changes the way people experience what an AI system can do. Instead of only classifying data, detecting patterns, ranking options, or predicting outcomes, these systems can produce new outputs that resemble artifacts people create in professional work. They can draft text, generate images, produce code, summarize material, and support other forms of content generation. That ability has made AI feel more visible, more interactive, and more connected to everyday knowledge work. Generative AI refers to systems designed to create content rather than only analyze existing content. That content may be a paragraph, a report, a line of code, a visual image, a design concept, or a structured response to a user's request. Large language models are a major form of generative AI because they are trained on massive collections of text and learn statistical relationships among words, phrases, concepts, and patterns of language use. When a person enters a prompt, the model does not retrieve a fixed answer in the way a simple database query might. It generates a response by predicting and arranging language in ways that are shaped by its training, the prompt, and the surrounding context. The importance of large language models comes from the central role language plays in human activity. Much of professional life depends on reading, writing, explaining, comparing, documenting, coding, questioning, and interpreting information. Because language is connected to so many forms of work, a system that can operate through language becomes useful across many settings. In education, it can help explain concepts and support feedback. In business, it can assist with reports, customer communication, analysis, and planning. In software development, it can help generate code, debug errors, and translate requirements into prototypes. These examples are connected by one larger point. Language gives AI a flexible interface for many kinds of tasks. The slide also emphasizes that generative AI can create images, software code, and other complex outputs. This matters because modern AI is increasingly multimodal, meaning systems are not limited to one form of information. A multimodal AI system may work across text, images, audio, video, numerical data, and code, allowing users to move between different kinds of representation. A user may describe an image in words, ask for code to analyze a dataset, or request a written explanation of a visual pattern. The system's value comes from connecting these formats into a coherent workflow rather than treating each format as a separate task. At the same time, evaluating the role of generative AI requires more than admiring its outputs. These systems can be powerful, but they can also produce errors, unsupported claims, biased responses, insecure code, or content that appears confident without being reliable. This is why generative AI should be understood as a tool that expands capability, not as an automatic replacement for expertise, judgment, or verification. A large language model may help a professional move faster, explore alternatives, or produce a first draft, but the human user still has responsibility for checking accuracy, appropriateness, ethics, and context. In serious applications, the question is not only whether the model can generate something, but whether the generated output can be trusted for the purpose at hand. This point is especially important because generative AI is often integrated into larger workflows. A model may be connected to search tools, databases, enterprise systems, analytics platforms, or application interfaces. In those settings, the large language model may serve as the conversational layer that helps users interact with complex systems underneath. It may translate natural language into queries, explain results, draft decisions, or help coordinate steps in a process. This role makes LLMs powerful because they can reduce the gap between human intention and technical execution, but it also makes governance more important. So when the slide says that generative AI and large language models are transforming modern AI, the transformation is not only about impressive outputs, it's about a change in the relationship between humans and machines. AI systems are becoming more conversational, creative, adaptive, and deeply embedded in the tasks people perform every day. They significantly expand the capabilities of AI systems because they allow artificial intelligence to participate in communication, creation, coding, design, and decision support. Our responsibility is to evaluate that expansion carefully, recognizing both the productivity it can unlock and the discipline required to use it well. In this slide, we move to the third learning objective, which asks us to assess the potential economic and workforce impacts of artificial intelligence technologies. These technologies will influence how organizations structure work, how employees build skills, how managers evaluate productivity, and how societies prepare for changing labor markets. The starting point is that AI does not affect all work in the same way. Some tasks may be automated, while others may be augmented. And that difference is central to workforce transformation. Automation means that an AI system performs a task that previously required human effort. In some cases, this may involve data processing, document classification, scheduling, customer support, fraud detection, transcription, or standard reports. When tasks are repetitive, rule-based, structured, or dependent on pattern recognition, they are likely candidates for automation. But automation should not be confused with the disappearance of an entire occupation. Many jobs are bundles of tasks, and AI may automate some pieces while leaving other pieces, especially those involving judgment, accountability, communication, or complex context, in human hands. Augmentation is different, and in many organizations it may be even more important than automation. When AI augments work, it helps people perform tasks more effectively rather than fully replacing them. A professional may use AI to draft a document, analyze a data set, summarize research, generate code, identify anomalies, or compare decisions. The worker still brings domain knowledge, ethical judgment, experience, and responsibility, while AI reduces time spent on lower level tasks and expands the ability to handle complex information. In this sense, AI can become a productivity tool, but only when workers understand how to use it critically. The slide also points to changes in labor markets. Labor markets change when demand rises for some kinds of work and declines for others. As AI becomes more capable, employers may value workers who can supervise intelligent systems, interpret AI outputs, manage data, design workflows, and evaluate model performance. At the same time, workers whose roles depend heavily on routine tasks may face pressure if those tasks can be performed more cheaply or quickly by automated systems. The actual impact depends on education, strategy, regulation, investment, and how quickly industries adopt AI. Job roles will also evolve. A role that exists today may not disappear, but its responsibilities may look different in the future. An analyst may spend less time preparing summaries and more time validating insights and advising decision makers. A developer may spend less time writing routine code and more time reviewing generated code, testing systems, and managing security concerns. A manager may use AI dashboards and forecasting tools, but still needs to know whether the recommendations are fair, reliable, and aligned with goals. Workers will need to adapt as AI tools change. New skill requirements are therefore a major concern. Technical skills will matter, but they will not be the only skills that matter. Workers will need AI literacy, which includes understanding what AI can do, where it fails, how to evaluate its outputs, and when human oversight is necessary. They will also need data literacy, because AI systems depend on the quality and interpretation of data. Communication skills, critical thinking, ethical reasoning, and domain expertise will remain important because AI-generated outputs still need human interpretation. The future workforce will be shaped by who has the opportunity to work intelligently with AI. This is why organizations and policymakers must prepare for workforce transformation. Organizations need to think beyond purchasing tools and ask how AI will change roles, training, hiring, evaluation, governance, and employee trust. Policymakers need to consider education systems, reskilling programs, labor protections, inequality, and support for workers affected by disruption. If AI increases productivity but concentrates the benefits among a small group of firms or workers, the social consequences could be serious. If AI is introduced thoughtfully, however, it can support new forms of work and improve organizational capacity. The central lesson is that AI's economic impact is not predetermined. The technology creates pressures and possibilities, but people and institutions shape the final outcome. AI can automate tasks, augment workers, change labor markets, transform job roles, and create new skill demands. Whether that leads to broad opportunity or deeper inequality depends on decisions made by organizations, educators, governments, and workers themselves. A responsible approach requires preparing for disruption while designing systems that help people adapt, participate, and benefit. This slide asks us to compare optimistic and critical perspectives regarding the future of artificial intelligence. That word compare matters because the goal is not to choose one side too quickly or treat AI as entirely positive or dangerous. A serious analysis recognizes that technological change often produces benefits and harms at the same time. AI may create innovation, productivity, and scientific discovery, while also producing employment disruption, inequality, governance challenges, and social stability concerns. The optimistic perspective begins with innovation. From this point of view, AI expands what individuals, organizations, and researchers are able to do. Systems that recognize patterns, generate content, optimize decisions, and support complex reasoning may help create new products, services, and methods of solving problems. In business, this could mean faster design cycles, smarter logistics, and better decision support. In education and healthcare, it could mean adaptive tools and improved access to information. The optimistic argument is that AI can extend human capability rather than simply replace it. Productivity is another major part of the optimistic view. When AI systems handle repetitive or time-consuming tasks, people may focus more attention on judgment, strategy, creativity, and human interaction. A worker who uses AI to summarize documents, draft reports, analyze data, or generate code may produce more output in less time. At the organizational level, this can reduce costs, improve speed, and allow teams to take on work that would otherwise be too large or too complex. In this view, AI becomes a general purpose technology that changes coordination across many sectors. The optimistic perspective also emphasizes scientific discovery. AI can help researchers search through enormous data sets, identify patterns in biological systems, model climate processes, support drug development, and generate hypotheses that guide further investigation. Scientific work increasingly depends on the ability to process complexity, and AI can assist with forms of complexity that exceed ordinary human calculation. That does not mean AI replaces scientific judgment, but it may accelerate research by helping humans explore possibilities more efficiently. Many optimistic thinkers therefore see AI as a tool for expanding knowledge itself. The critical perspective does not deny these possibilities, but it asks who benefits, who is harmed, and what risks are being ignored. Employment disruption is one of the most immediate concerns. If AI automates tasks faster than workers can adapt, some occupations may shrink, wages may be pressured, and people may be forced to retrain under difficult conditions. Even when entire jobs are not eliminated, workers may experience changes in status, autonomy, workload, or surveillance. A critical analysis asks whether productivity gains will translate into shared prosperity or primarily benefit the organizations that own and deploy the technology. Inequality is closely connected to that concern. Advanced AI systems often require data, computing resources, technical expertise, and institutional capacity. Large firms and wealthy countries may be better positioned to capture the benefits, while smaller organizations, less resourced schools, and vulnerable communities may fall behind. There is also the risk that biased data or poorly governed systems can reproduce discrimination in hiring and lending, healthcare, education, and other areas. From the critical perspective, AI is not only a technical system, it's also a social system that reflects existing power relationships. Governance challenges are another major part of the critical view. AI systems can be difficult to explain, audit, and control once they are embedded in large platforms and institutions. Questions arise about accountability, privacy, intellectual property, safety, transparency, and responsibility for harm. If an AI system affects a person's opportunity, finances, health, or legal status, someone must be accountable for how that system was designed and used. Governance becomes more complicated when AI tools spread faster than the laws and professional standards can respond. Finally, this slide raises concerns about social stability. Given rapid technological change can create anxiety when people feel that institutions are not prepared or that the benefits of innovation are unfairly distributed. Misinformation, job insecurity, concentration of power, and loss of trust can weaken social cohesion. This does not mean that AI inevitably creates instability, but it does mean that ignoring these concerns would be irresponsible. The most informed position is not blind optimism or automatic pessimism. It is a balanced perspective that recognizes AI's potential while insisting on careful design, fair access, strong governance, and preparation for the human consequences of technological change. This final slide brings the module to its main intellectual task, forming an informed perspective on the long-term implications of artificial intelligence. That phrase matters because it asks for more than a reaction. It does not mean being excited by AI, suspicious of AI, or impressed by the newest system. It means evaluating evidence, comparing arguments, recognizing uncertainty, and understanding that AI will develop through technical progress, economic incentives, organizational choices, and public decisions. The future of AI is not something we merely watch. It is something people and institutions actively shape. To formulate that kind of perspective, we first need to evaluate competing views about AI's future. Some views emphasize growth, efficiency, scientific discovery, and the expansion of human capability. These arguments are serious because AI can help people work with information, automate routine tasks, generate useful content, and support complex decisions. Other views emphasize disruption, inequality, misinformation, labor displacement, and governance failures. Those concerns are serious as well, because powerful technologies often magnify existing social and economic pressures. A careful perspective does not dismiss either side too quickly. It asks what conditions would make optimistic outcomes more likely, and what failures would make critical outcomes more severe. Long-term implications also require us to think beyond immediate productivity. In the short term, organizations may focus on whether AI reduces costs, improves speed, or helps employees complete tasks more efficiently. Those are important questions, but they are not the whole picture. Over a longer period, AI may change how knowledge is produced, how expertise is valued, how education is designed, how decisions are justified, and how people understand their role in work and society. When a technology becomes part of communication, analysis, creativity, and judgment, its influence reaches deeper than simple automation. One long-term implication involves dependence. As AI systems become more useful, individuals and organizations may rely on them for decisions, explanations, and creative or analytical work. The concern is whether users understand the strengths and limits of the systems they depend on. If people accept AI outputs without verification, errors can spread through decisions that appear efficient but are poorly examined. Responsible use requires oversight, where AI supports human reasoning without quietly replacing accountability. Another implication involves access and power. Advanced AI systems are not distributed equally. They require computing resources, data, expertise, infrastructure, and governance capacity. If only the largest firms, wealthiest institutions, or most technically advanced countries can control the most powerful systems, AI may intensify existing inequalities. At the same time, accessible AI tools may help smaller organizations, students, workers, and communities participate in activities that once required specialized resources. The long-term question is not only what AI can do, but who can use it, who controls it, and who benefits from it. We also need to consider responsibility. The slide reminds us that guiding future AI technologies involves obligations, not only opportunities. Developers should build systems that are reliable, secure, transparent where possible, and tested against foreseeable harms. Organizations should deploy AI in ways that respect privacy, fairness, safety, and human dignity. Educators should prepare learners for a world where AI literacy is part of professional competence. Policymakers should create rules that protect the public without freezing innovation. Users also have responsibilities. because every use of AI involves choice about trust, verification, context, and consequences. This is why the future of AI should not be framed as a simple contest between progress and fear. The better question is how societies can guide progress so that benefits are real, risks are managed, and human judgment remains central. Artificial intelligence will likely influence industries, labor markets, scientific research, education, public administration, and personal life. Some effects will be intentional, and others will emerge in ways that were not fully predicted. A mature perspective accepts uncertainty while still demanding thoughtful design, governance, and ethical awareness. As we close this module, the most important takeaway is that the long-term implications of AI are not only technical, they are economic, ethical, social, political, and human. The systems themselves matter, but so do the values embedded in their design and use. AI may help solve difficult problems and expand human capability, but it will require disciplined judgment to ensure that its development serves people rather than merely accelerating systems of power, profit, or convenience.